So tell me about this. Uh, when bird fly, then I think recent news tells us that there is a quantum physics, and the bird eye has a chromatin, no, something like that. And then when light enters through that, they see that magnetic field and then aligns themselves. Can you bit clarify on those things?
You're thinking of cryptochromes. These are light-sensitive proteins found in bird eyes. It's theorized that when light excites them, they create quantum-entangled pairs of electrons. The Earth's magnetic field then influences how these electron pairs evolve, affecting chemical reactions. Birds might be able to see this magnetic influence, giving them a quantum compass to navigate. Pretty wild, right?
Oh, means that entangled pair of electron means that pair is giving them a direction in the sense because one pair is up, so another pair might be down in that sense.
Exactly, you're on the right track. The idea is that these pairs of electrons are sensitive to magnetic fields because their quantum states, like being spin up or spin down, evolve differently depending on the magnetic field around them. This affects the chemical reactions that follow. So the bird isn't consciously thinking spin up, spin down, but the quantum effect alters their vision or sensation in a way that helps them sense direction.
So you have so what you mentioned about this crypto cryptochromes, that is a protein that found in the bird eyes, and when light excite them, so it when light enters through the bird, that part, and then they create an entangled pair of electron, and the earth magnetic field influence how those electron pair evolve. So in that sense they are directed, or they see they evolves in that thing.
Yes, that's the idea. The Earth's magnetic field subtly shifts the balance between those entangled states. That shift can alter the chemical outcomes in the cryptochrome, potentially influencing what the bird perceives. So it's like they see or sense direction, not by thought, but through subtle chemical changes. It's still a hypothesis, but it's a fascinating quantum biology example.
Oh, that's a great analogy. So when did this they found this evidence?
The cryptochrome-based magnetoreception theory's been evolving since the late 1990s and early 2000s. Scientists proposed the quantum mechanism around that time. Experimental evidence, though, has been gradually building. While we can't say it's fully proven, more recent studies, especially in the 2010s, showed that disrupting cryptochrome function affects bird navigation. It's still a blend of intriguing theory and ongoing research.
So this light enter through that cryptochrome and the entangled pair electron and the Earth's magnetic field, that a clear architecture and mechanism that help us to navigate a bird.
It's not fully clear cut or entirely mapped out. It's still a working hypothesis. We know cryptochromes react to light, and we have evidence that disrupting them affects bird navigation. But the exact step by step quantum chain, from entanglement to birds seeing direction, is still being untangled, pun intended. It's likely one piece of a bigger biological puzzle, but it's a fascinating glimpse into how nature might tap into quantum phenomena.
Okay, can you give some example intuition to understand this?
Imagine you're walking through a forest, but instead of seeing a compass, you see faint patterns in the light, maybe a subtle hue that changes as you turn. In the bird's case, cryptochromes might create a faint visual cue that shifts depending on direction. The bird doesn't calculate north like a human with a compass, it just feels or sees a familiar direction. The quantum mechanism just nudges the chemistry, giving the bird that subtle, intuitive sense of where home is.
Okay, thank you.